Hey guys, Aaron with Grandpa Ray's. Today in seminar 3, we're going to jump into two things that we really need to get a basic understanding of so that when we put all of this together with the soil and the microbes and the nutrition, and we start to see how all these seminars are going to intertwine and paint a really clear picture for us of what we're doing, and how we're doing it, and whether we're having negative or positive effects to the final goal, which I hope for most of us is to have the most palatable, nutrient dense food plot that we can have for our deer. So today what we're going to be talking about is we're going to be talking about successional growth, and then we'll go into the soil food web. So it'll be kind of a basic rundown. If you guys have questions that go a little deeper, I'd be happy to answer those. But I want to just give a basic understanding today so that we have a footing, foundation laid for us to move on. So first of all, what is succession in ecological terms? And succession is the change in the plant communities, the species composition, the structure at a site over time. And at each stage of succession, the plant community alters the soil and microclimate, thus facilitating and establishing the next group of plant species. So there's two primary types of succession, or two types of succession, the first being primary. So when we talk of primary, we're talking, okay, the earth is cooled, we have rocks, where are we going from here? So bare rock into old growth forest is the primary succession. And so you're starting with little or no soil, you're ending up with an old growth forest. Secondary succession is you have an area that has gone so far in the succession scale, and some event has occurred that has brought that back down the scale of succession, though. So for mostly what we're going to be talking about secondary succession, but we still need to understand what actually happens during succession. So this is one slide that I found that I think encompasses a lot of different things for us and allows us to get a basic understanding of successional growth. So if you have a piece of ground that does not have any plants on it, what you're going to see is pioneer weeds are going to come into that soil. The reason being is because that soil cannot support anything other than them primary weeds. It has a very high bacteria concentration. There's little to no fungal population in that soil, and because of that, there's very little protozoa or life that can help cycle nutrients. There's very little plant available nutrients in that soil. Now, as we talk, the nutrients are there, but they're not in a usable form that the plants can use. So we've got a very high content of nitrogen, because it is bacterially dominated. Bacteria are going to give you nitrate. And when we talk about what our plants need and what is available, you've got the nitrate on the far left, the soils that don't have the fungal biomass, don't have the high population of protozoa. There's nothing that is cycling those nutrients. So as we move from the pioneer weeds, the annual weeds, nature seeks the vacuum. Anytime that there's bare ground, Nature is going to want something to grow there. And due to the poor health of that soil, the weed population is the weeds are what's going to take hold. And they're going to take hold because they're the only plants that can successfully grow in that soil. They're going to grow, they're going to spread their seeds, they're going to grow. Now, as that's happening, slowly over decades, the plant material is then being left on top of the soil, it's decomposing, and now we're introducing very small amounts of fungal food, and we can move into some more perennial weeds, more perennial plants that are in that stage of growth that they can deal with a high bacterial percentage, but has a little bit of fungal life in there also. So we've got, from there, as we get that established, we move into our early successional plants. We're getting close to that 3-to-1 bacterial to fungal ratio. So we're reducing the bacteria and we're upping the fungal content of that soil, and that gets us into our brassicas and some of the early grasses. And as they're dying and adding to that old horizon, and those plants are getting decomposed, and that humus is going into the soil, and you can see that this is a progression. We're growing that topsoil. We're growing the ability for plants that are further down in that successional line to be able to grow. So after that, our next step gets into our row crops, which when we think of our grains and we think of our beans and highly productive pastures would be our clover blends. So now we're into that 1-to-1 ratio. We've got an equal amount of bacterial biomass as we do fungal biomass. And we just keep moving right on down the line. As the fungal biomass starts to grow beyond what the bacterial biomass is, now we can start to see some woody plants grow. We start to see our brushes and our vines. And as we will talk about when we do the composting seminar, woody materials is the fungal food. So now not only are we growing some more organic matter that we can decompose, we're actually growing the exact food that the fungal species like. So then you add the food to the system and the fungal population can grow. And we move on to our orchard trees, and from there to our deciduous trees to the old growth forest. When you get up to deciduous trees and conifers and old growth forest, you're looking at fungal to bacterial ratios of 10 to 1,000 to 10. I mean, there is a massive amount more fungus in the soil than there is bacteria. So it's a scale that kind of it goes from the highly bacteria laden dirt starting to be soil all the way through to the old growth fungal dominated soil at the other side. And as you can see, the pH can actually be changed over time also. And that's a direct result of what biology is living in that soil. If we're shooting for that perfect pH, and you look at it on the scale on the bottom, that's right where those row crops kind of come in. As you get down towards the weed, we're very low in organic nitrogen. Ammonium is the nitrogen that the plants can take up. Nitrate is the nitrogen that's very difficult for the plants to take up. And if you're very bacterial laden soil, you're going to have nitrate. As you start to balance that ratio of the biomass of bacteria to fungus, now you're going to have nitrate and ammonium in the soil, and ammonium is easily uptaked and usable for plants. And then as you move on to the far right, and we're getting into our old growth forest, that's heavily dominated with ammonium versus nitrate. So looking at this from a food plotter stand of view, we've kind of went over the whole thing, but where we need to concentrate is in what I've got circled in red here, which would be basically from the very low organic matter through the row crops, which would be the top end of what we're looking to establish. So a couple things that we need to consider when we're looking at this is, why doesn't every piece of soil go through this successional growth and become fertile? And that is because of two major reasons. And then Mother Nature would be number one, with weather events, with droughts, with high volumes of rain, wildfires, stuff like that that can disrupt this succession from the one side to the other. The other major factor is us. There is no faster way to ruin a system than with some of the practices that we are using often while we are doing our gardens, our food plots, or even our egg fields. If we would have a row crop, which is towards the higher end of this circled area on our successional plot, and we know that we have a close to 1-to-1 bacteria to fungal biomass, and we harvest that crop, and then we come through and we till that field, by our actions, we have taken that 1-to-1 and brought it all the way back to our heavily bacteria-laden soil. So we have set back what would take nature hundreds, maybe a couple hundred years to be able to develop. We are destroying that fungal biomass and returning that soil back to a heavily bacterial dominated soil. And with that, we have now opened that area up to that the most successful plant that can grow in that soil are our pioneer weeds. So when we look at our weed problems, we have to have that understanding that part of the reason that them weed problems are there is because we have disrupted the succession of that soil. We have taken what took 3 months. I mean, in order for a fungal colony to get a foothold and establish, it takes 3 months. And in one day, by ripping that field up, tilling that field, we have set the clock back and brought that soil back into a soil that only weeds can grow. So we have actually disrupted that system. And when we wonder why we're having this weed problem, we have to understand that the reason that we're having the weed problem is because of what we did. We caused that. What we've also done is we've changed that bacterial, not the biomass. We've still got that heavy bacterial biomass, but we've changed the type of bacteria. So now we're back to bacteria that are producing high amounts of nitrate, which again are not easy for the plant to consume, although certain weeds are built to live off of nitrates. So again, when we do that flush, we till that field, we have all that air go into that dirt. We've chopped up all that plant residue into these fine pieces. The bacteria go wild, and there's a bacterial flush They release a bunch of carbon into the atmosphere and a bunch of nitrate into the soil. So we've actually disrupted that process and caused our own issues. The other interesting thing that we need to look at is, as you look at the successional growth here, from the pioneer weeds to the next layer, we see that the brassicas come before the row crops. So we already discussed that the row crops like that 1-to-1 fungal to bacteria ratio. Our brassicas actually prefer a 1-to-3 fungal to bacteria ratio. So the brassicas in succession can grow on a little poorer soil than our row crops. So that's something to really take into consideration, and maybe ask ourselves a question is, if we are going to develop our soil to grow what we want, do we want to be growing row crops in the same plot as our brassicas the following year? Maybe that's a question we need to start asking is, do we need to rotate different species of brassicas in the same plot to develop that 1-to-3 fungal to bacterial ratio and not disrupt that by trying to bring row crop into that the following year and trying to get that to 1-to-3? Or do we look at that as, we've got a 1-to-1 in our row crop, but we know we're going to disturb it a little bit and we're going to drop that, so the following year it might be set up for our brassicas at that 1-to-3. The other thing that we do other than tilling is pesticide and herbicide use. They're built to be antimicrobial. They will set that back. You will be trying to grow that fungal to bacterial biomass, and you come through and you spray it, and now you're sitting with soil that you have taken back, something that could have took nature hundreds of years to do in one application of a herbicide. So food for thought. We could go a lot deeper into this, but I just wanted you guys to have the understanding of what the successional growth cycle looks like and how we can disturb it and bring things back. Now there's things that we can do, and we'll start to go into that sooner, or here coming up in the next seminars that we're going to do. It takes nature hundreds of years to move from one successional growth phase to the next successional growth phase, but we can skip or speed up the process by having an understanding of where we are and adding the biology to the soil. So that's a brief overview of the successional growth, and we will move into, so now we move into the soil food web. One of the first things that we need to understand with the soil food web is that's what's making those plant available nutrients available to our plants. So when we look at the soil food web, we need to understand the bottom of the chart first, with the trophic levels. So the first trophic level is the photosynthesis. That is the plants taking that sun energy and converting it to sugars, proteins, and carbohydrates that allows the plant to grow and also allows that plant to create the exudates that it uses to exchange the sugars with the biology in the soil to get the other nutrients that that plant needs in a usable form. The other thing that photosynthesis creates is the matter. It's the organic matter of the plant that we've talked about before, breaks down, creates that O horizon, which gives us that humus that eventually creates the humic acid, fulvic acid in the human that we've already talked about the benefits of that to the soil. So the first trophic level is the process of photosynthesis. And then we move into the second trophic level, which is the small bacteria and the small fungi and nematodes that are breaking down that plant material. It's the decomposers. It's the first layer that's creating the food that they need to live. So the the second trophic layer is eating the carbon material of that first trophic level. When we get into the third trophic level, now we're starting to get into the nuts and bolts of the system. Our third trophic level has our shredders, which is taking that plant material and breaking it down into smaller pieces that's easier for the second trophic level to decompose. But it's also the level that we start to see the first predators. And predators is the key to the nutrient cycling. As you move on to the fourth and fifth and higher trophic levels, all you're doing is you're increasing to the next predator level that is consuming the prior predator level. So as we look at this, how does that create nutrients? Well, what we need to start looking at when we're looking at the predators is we start to look at the relationship or the ratio of carbon to the mineral or nutrient that we're looking for. So every living being has a carbon to nitrogen ratio, a carbon to phosphorus ratio, carbon to boron, carbon to magnesium, etc. But they all differ. So when we're looking at the carbon to nitrogen ratios, say of a plant, you're looking at 30 to 1, which is similar to humans. Humans are also 30 to 1. When you look at a bacteria carbon to nitrogen ratio, it's 5 to 1. So on the bottom of the chart, you see the bacteria, and we look at that, and that bacteria is 5 to 1 carbon to nitrogen ratio. And that protozoa, which is in the next trophic level, comes onto that bacteria, which is its food. A protozoa is 30 to 1. It's very similar to what we are as far as carbon to nitrogen ratio. So in order for that protozoa to get enough carbon when it eats a bacteria to reach that 30 to 1 ratio, that protozoa needs to eat 6 bacteria to get sufficient carbon. Now, while that protozoa eats that bacteria and obtains the sufficient carbon, so bacteria was 5 to 1, it needed to be 30 to 1, so it ate 6 of them to finally reach that ratio that it needed. What it ended up with was extra nitrogen, because the bacteria was 5 to 1 and the protozoa is 30 to 1. By eating that bacteria, it obtained 6 nitrogens when it was eating enough bacteria to get that 30 carbons. So what does that protozoa need to do? Well, it needs to live at that 30 to 1 ratio. So because of that, that protozoa has to get rid of those extra 5 units of nitrogen. Where this benefits us is as a protozoa poop, I mean, that's what we call this, is the poop loop, the extra nitrogen out into the soil, that nitrogen is now in a plant usable form. So through that process of that protozoa eating that bacteria, it is now providing our plants with nitrogen. And when you look at a protozoa and realize that protozoa can eat hundreds and thousands of bacteria, and we start to calculate the amount of nitrogen that can create for our soil, we can start to understand that the life in the soil, the biology, is really what can provide us the nutrients we need for healthy growing plants. And as you move up that food chain, it just keeps happening again and again and again. And again, even though we use the carbon to nitrogen example, we have to realize that at the same time, there's also carbon to boron, carbon to magnesium that's happening, where those extra nutrients are also getting released as this process of the food chain, the soil food web, and the predators eating the lower trophic levels is happening, creates the nutrition for our plants. But going back to our discussion that we had on successional growth, if we don't have the proper soil to house these trophic levels of creatures, we can end up with unfertile soil that we then need to come in with amendments. So that's a kind of a quick shot at the soil food web, just giving you guys an understanding of how that happens. We could really get in. I mean, when you look at fungi, you're starting to look at carbon to nitrogen ratios that are through the roof, where you could have carbon to nitrogen ratios as high as 1,000 to 1 in some instances, and you start to look at the capability of fungi to add nutrients to the soil. That's when you really start to see how much nutrients you can have the biology in the soil produce for you. But only if we let our soil get to that stage of successional growth where those fungi can live and be doing the work that we need them to do. So I just wanted to touch on these two things for you. We can go into these further in depth in the future. If you guys have questions or you want to focus on a certain aspect of any of these, just let me know and we can dig down deeper into some of that. But a basic understanding of successional growth and the soil food web is what we need in order to start taking our food plots, our gardens, our egg fields to that next level. And the great thing about it is once we start farming our biology and farming our soil and stop worrying about farming whatever the food plot crop or vegetables, it's easier. Once we hire these guys to do the work for us, they take care of our predator control, they take care of our nutrient management, they take care of our soil management because they're building structure in the soil, and we can spend more time hunting. So hope you guys got a little bit from this today, a little food for thought, something, as John would say, to ruminate on. And we'll see you in the next seminar. Aaron with Grandpa Race.